it is in equilibrium condition. So if you case for binary joint, this has some structure. So here in this case also same. Now it's under equilibrium. For this in this case, this is also under equilibrium. So if you say for the object here, net to force equilibrium, suppose the some force is Fa, some force is Fb. Okay, so Fa and Fb which are not in same magnitude, so it is not satisfied. Okay, not in equilibrium. Even though this is acting in this direction and this is acting in this direction, it is not acceptable. So if you say for this condition, second condition, the one force is acting in this direction, the one more force is acting in this direction. Getting my point? So this is also not accepted. For this third case, the two forces are there which are passing the same line in opposite in direction. Now this is in equilibrium. F of x is equal 0, sigma m is equal 0. So simply said, F is equal mm mass into acceleration. So if there is a two force acting the same, it's for your information. Now this all condition is accepted. Now the object is in under equilibrium condition. Okay? Now for this second equilibrium of three force members. So equilibrium of three force members is a binary ternary joint. Ternary joint. So if you see where we have to use ternary joints, particularly see in JCBs. So in place of here JCBs is a ternary joint. It's a one of the ternary joint. So if you see this ternary joint and here in place of here in this arrangement, here one arrangement hook arrangement is there. There is a ternary joint. Okay. So there's application of ternary joint. Now for this ternary joint also there are some condition when object is in equilibrium. So if there is a B, C, the point A, B, C, 1, A, B, and C, the points are A, B, C, it's a ternary joint. So this type of joints are equilibrium under applying several conditions. So let us see, first condition is resultant of forces is 0. So if you see the resultant of forces, so now if you say one force, second force, third force. So if you say the resultant of these two forces moving in this direction, one force is moving in this direction, this is not an equilibrium condition. So it is not satisfied. Suppose in case of, you see, one force is acting in this direction, one force is acting in this direction, no one force is acting in this direction. Now the object is in the chance of equilibrium. So now this under equilibrium. Now the line of action of force intersect at a point. So it says the line of action of force, the line of action of force intersect at a point. This second condition. So what is this line of force of intersect? What intersecting? So let's see. So let's see. One force is acting in this direction. Okay. So now force is passing from here in this direction. So one force is passing, one object force is acting in this direction. Okay. Passing. So when these two forces are passing in this direction, then it should be intersect a particular point here. Intersect particular point here. So from this point, the one more force should be opposite and that should be passed through the one more given point. So now let's see, one force is acting in this direction. Now the object is satisfied. So here is that for this whole condition, it is satisfied first and second. Okay. Now see the line of action, forces intersect a particular point and resultant force must be 0. See this figure. Okay. So the first condition and this for second condition. So if you say first condition forces must be 0, only forces must be 0 for this, it's okay. Because all the forces are parallel. All parallel, there's some coplanar. Now this must be satisfied. For this condition, the line of action of force intersect a particular point. Now that point is here. Okay, from this point, one force is A, one force C, which are in the moving in upward direction, which is tries to lift the object in upward direction, and which meet at a particular point, and there is some forces passing a downward direction. So here now this condition is satisfied. Okay. Now if you see here, it's two conditions moving up and down, lifting the object or lifting the man. So this one and reverse condition also accepted here. So while object is in satisfied these two conditions, then we can say that forces means that three forces members are in equilibrium condition. The three force members are in equilibrium condition. Okay. Now, till now we have understood that all these structural parts, so must be satisfied either two force members or three force members. So this entire the structural object which is fixed with respect to all this respect to given equilibrium conditions. Okay. If you have time, just go in outside and just observe the how structural members are made. So if you see one structural members are made in this manner. Okay. And the one rooftop is there. Suppose there's some load is applied on this way. From there some load is applied. So here it is a fixed. So here it is also fixed one. So now these types of structure made. Now this, so if you say this member, this output member load acting here, that should be resist with the help of here. Merely this V shape of these two members with respect to of these two supporting members. These two members should be lifted. Okay. So this type of